గురు రికార్డ్ మోడ్లో పెట్టావా? రికార్డ్ మోడ్లో రికార్డెడా? తక్కువ ఉందా? ఇది దించితే కనబడుతుంది ఫస్ట్. ఎట్లా ఆపితే కనబడుతుంది.
ఓకే సార్, అది కొద్దిగా సెట్ చేయాలి సార్. ల్యాబ్
ఫుల్ స్క్రీన్ కనబడుతుంది. ముందు ఫస్ట్ ఇక్కడ పెట్టి చూస్తాను. సరిపోతుంది.
ఓకే సార్.
Okay, so I'm going to start with the plots first. Then after finishing the plots, I'll jump to functions. In the functions, we will see whether we take the input arguments. అక్కడ కూడా ఒకటి ఉంది. Okay. That's enough. Because some of the buttons are connected to the projector. And if you unknowingly stop, again it will take 10 more minutes. Yeah. So we've been looking at the plot commands, and again in the plot commands, whichever is essential for our lab, I only demonstrate those plots, and other parts I will skip because if you're going to talk, it will be a vast the course. So whichever is essential for programming in your academic curriculum, the syllabus, I only handle those parts. So in MATLAB, we can do 2D plots, we can do 3D plots also, and in fact, you can draw the contours, bar plots, statistical plots, all grid diagrams. So all the types of plots we can draw on the MATLAB, even in the three-dimensional also. But we will focus only on the 2D plots, and we will focus only on the normal plot commands. So just look at the normal plot commands. Majorly we use inbuilt functions. The first inbuilt function is plot, 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 which gives a linear plot. Plot command will give the linear plot, and then grid means it will give the grid lines. When I apply the grid function called grid, the inbuilt function called grid, it will give the grid lines. And in order to keep name x-axis, I use called x label, XLABEL. Label also very important because most of the time people will write LABLE, so it won't work. LABEL label, X label will give the name to the x-axis. Similarly, Y label will give the name to the y-axis. And there is a command called title, which can give the title to your figure, TITLE. and there's called another function called subplot in figure we will discuss. See, the syntax for plot in MATLAB is PLOT plot, normal parenthesis, X, that is the x-axis which you want to plot, Y, y-axis which you want to plot, separated by commas, and then a single quoted, and then we will write whichever index we want for the color to print. MATLAB has diversity of colors, diversity of the symbols. So whichever color I want, I can print it in that color graph. Whichever symbols I want in that symbols mode, I can print it. So this is called marker, line, and color. So in the single quoted, I can use whichever color I want, whichever parameter marker I want to use, whichever style I want to use. If I don't want any color, if I don't want any style, I just keep it as this x comma y. Without using any color, if I don't want any color to graph, and if I don't want any style, any marker I don't want to apply, just leave it blank as it is. You will get normal plot. Okay. So if you press help color, the MATLAB help, because help is a user defined button. So that will give syntax for everything. Look at when I go for plotting, when I go for graphs, there is window will be open. This is called figure window. This is called figure window. And if you observe the figure window, there are different shortcuts are available. Just like when you open a Word document in Microsoft, there is a file, there is an edit, there is a view, there is a review. So there will be a lot of icons will be available. In a similar sort, in MATLAB also, when you open a figure, when you try to draw a plot, there will be figure window open, and you have all these shortcuts here. And the meaning of all these shortcuts is, after plotting the graph, from the figure window itself, you can edit it. Like, if I don't know the buttons called XLABEL, or if I don't know the buttons called title, what I can do, I can use these subheadings, and I can keep track of whatever I want to keep. For example, I want to keep the title by axis. From here options, I can go edit, go to edit, and there will be several icons will be there. Click on the y-axis title. So the cursor will automatically come over here, and you can type whatever name you want to give. Similarly for x-axis. Similarly for any title. Similarly for any labeling. Similarly for any legends. Similarly for grid lines. So without using the inbuilt functions like grid, xlabel, title, subplot, etc., even using these commands also you can keep on your figure window. Okay. Now you observe keenly the graph here. More often, MATLAB will give you the default blue color. It's a default blue color because MATLAB has kept blue color as a default. If I don't use any color, automatically the color it will appear is blue. Is it clear? Now look at the colors. I can go with red color. I have to use symbol called R. Green G. Blue B. So look at the different colors, different symbols. Look at the specifiers. Look at the marker types. For example, if I want graph to be with plus signs, plus, 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 similarly a sine curve with plus I want. So go with specifier called plus. So in the previous thing I have given here, the single quoted. K represents one color. And then I want dot with the dash. So two types is possible also. So I want both dot as well as hyphen. With hyphen dot, I should be a curve like this. So whichever marker style, whichever line style, whichever color style I can use in the single quoted. If I don't want anything, just skip this part. The color will be in blue color. Or the color which I want, for example, specifically I want black color. Look at the black. I use K. That's what K dot. So I want in black color, so I use K. So use colors, use specifiers to get variety of your plots. So advantage or the beautiness of MATLAB lies in plotting. In ancient time, not in ancient time, maybe if you look at maybe 15 years back, MATLAB is used only for video gaming and plotting commands. The children which they want to play video gaming, that's the first purpose of MATLAB in initial versions. Second version is for the researchers for the plottings. So there at that time, maybe before 15 years, there won't be any software called Mathematica. Have you heard about Mathematica? This is a big tool for plotting only. Mathematica is a software to only plot the graphs, but that is not available before 15 years. Only MATLAB is the only tool. Then after that, we have a lot of simulators or softwares like Origin. Origin is also very good software to plot. That means when you plot, it will be such a beautiful that the pixels will resemble your eyes. Origin software is now available. See, if you plot in Excel, it will be almost like ugly graphs. You look at the plots which you draw on the Excel, there will be always horizontal lines. Plot means there should not be available except the graph. You can pinpoint what is my x, what is my y coordinate. So that's what the graph. So the beautifulness of MATLAB is plotting. So look at the command C I have given here. The solid lines, if I want, I can use one hyphen symbol, dashed lines, two hyphen symbol, dotted lines, dot, dash dot. So many varieties are possible. And you can use hold on symbol. The one thing, if you use the plot commands, MATLAB will replace the current plot with any new one until unless you specify. What do you mean by that? Means if I written a statement called plot x comma y, that means there is a plot keeping x, keeping y, there is a plot came. Now after that, I used plot y comma z. What will happen? MATLAB will try to replace the original graph. That is, originally you have plotted xy, that will be replaced with y and z. And if you don't want to replace that one, I want both xy graph as well as yz graph, you should use command called hold on. Hold space on. That means hold on. That means keep the original graph and draw the new plot. Called command hold on. Hold space on. Okay. And then grid on, you can use the grid. And if you want a figure to be open, use figure figure command. We will see. See, here I have written, and the advantage of MATLAB is you can go with multiple plots on the same thing. Plot of x1 comma y1 comma s1 x2 comma y2 s2. That means on the same graph, I can put so many curves. That means, for example, I am plotting some temperature versus vapor pressure. Temperature versus vapor pressure. If I draw a plot, now for temperature versus vapor pressure, there may be benzene toluene graph, there may be water ethanol graph, there will be methanol ethanol graph. So on the same thing, I want to have the different plots. So I can use in a single statement. So all will be clearly labeled. Look at this one. X equal to 0 colon 0.1 colon 2 into pi. 2 means pi. 2 pi. 0 increment by 0.1 till you get 2 pi value. 2 pi is 3.14. So 2 into pi means. So go start from 0, increment by 0.1, the value till 6 point something. That will be stored in x. And then y is sine of x. That means whatever the value of x, y will calculate sine of x. And you are plotting plot x comma y in the red color, single quoted or dot Look at the graph now. So I want dot hyphen. See, I want dot hyphen, dot hyphen, dot hyphen. I want red color. So that is the beautiness of this plotting. The color you can change, the marker you can change, the line style you can change, and in fact, you can draw many plots on the same graph. Many plots on the same. That's what I told you. Vapor pressure, temperature for different systems, different VLE plots can be on the same graph, so that you can look at the variation. How my vapor pressure varies with the temperature for benzene, ethanol, ethanol water, methanol water. You can see on the same axis. You can see. And one more advantage of plotting is using a command called axis. AXIS. The advantage of axis is you can look at. We can alter the range. We can alter the range. That means if you go back to your plot. Now this is a sine plot we have drawn. Using plot XML, we have drawn this plot. Now, for instance, I want only this zone. I want only this zone. I do not want this part. I want to have only plotting this part. Only, I want to see only this segment. What I can do is I can use command called AXIS. 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 Normal parenthesis, square brace, right x min, right x max, right y min, right y max, close it. That means what is the range of x-axis to be plotted, what is the range of y-axis to be plotted, you should cut it down. For example, this part, see, minus 2 to 2, minus 2 to 2. That means x minus 2, go till minus 2, y minus 2, go till 2. Look at the plot. Only x minus 2 2 plus 2, y minus 2 2 plus 2 is taken. Only that portion of the graph is shown to you. That's called command called AXIS. So the range within which you want your plot to be displayed is shown. If you want only the particular portion of the graph, so take out. Syntax is AXIS, x min x max, y min y max. Let's see the subplots. See, the name implies plotting sub. Plotting sub means I can use plotting by subsections, by cutting subsections, plot subsections. That means the command is all the time the complete window of the figure will be broken into the number of parts which you mention. The number of parts which you mention. For example, in the same figure window, I want only two plots. Maybe sometimes you may watch in movies. The entire screen will be broken into 4 segments or 10 segments, where every segment has one picture. Maybe here hero will be there, somewhere heroine will be there, somewhere villain will be there. So complete window will be demarked or broken or sub-pieced into several sections. In figure also, you see, this figure window was broken into 4 parts. You see, this is figure 1, this is figure 2, this is figure 3, this is figure 4. So I can cut down to a level which I want. Further, there is a command subplot. So what is the syntax for subplot? Maybe I can show you. Yes, subplot. Subplot, horizontal, vertical, figure number. Horizontal, that means represents the rows. How many rows you want? Columns. how many columns you want. First index refers the rows. First index refers the rows. Second index refers the columns. Last index refers the figure number. So what do you mean by this now? Go back to the previous figure. Go back to figure. First refers the row. First index refers row. Second index refers column. Third index refers the figure number. So two means two rows, two columns. Two rows, two columns. Is it not two rows, two columns? See, first row, second row. First column, second column. Two rows, two columns. Four parts divided. In the four parts, I am talking about only plot number one. That means I am talking about this. So what is that? Plot T comma A. So maybe A here, T here, I got a plot. Now subplot 2 2 2. Two rows, two columns, second plot. So what is the plot? T comma B. Whatever it may be. So I can draw the plot using subplot command. Is it clear? So why we need this one? Because instead of plotting all the graphs on the single window, if I have some temperature versus velocity, here it may be temperature versus pressure, here it may be temperature versus humidity, so that everything can be visualized on the same window. Very much important in when we talk about the fluid flow operations, where we want to look at all the parameters from particular equipment. I want to look at these graphs. So subplot 2 comma 3 comma 1 means, so how many sections now? Two rows, but three. So how many figures will come? Six figures. So three figures will be on first row, three figures will be on the second floor. Okay. So is it okay now? The plot commands you understood, subplots you can understood now. So I'm moving to the functions now. Now look at the functions. As I discussed the functions, functions with input and arguments, functions with input and no output, functions with output and no input, functions with neither input nor output. Have I discussed this? Okay. So what is this meaning of functions is, when you write normal coding in MATLAB, you can also write the MATLAB code using functions. Just like in C, any program can be written using calling functions. If you remember in C programming, calling functions. We will write the program using functions. We will call that function so that one of the argument is copied and it will be transferred to the function which is called, and it executes, and the executed output is again sent to the called function. So there are two terms here: calling function, called function. Similar applicable to the MATLAB also. So division by 4. Either you can write programs using functions with input and output. That means you are calling or you are writing the program by sending the inputs as well as the outputs. Both input output arguments. Second classification, only with input arguments, no output. Third classification, only output but no input. Last classification, we are not sending any input, we are not accepting any output, but we will use functions for writing all the codes. Let's look at one example. Let's look at this program. This is a program for printing the Fibonacci numbers using functions. So we already know how to print a Fibonacci number. What is the logic I told you? I explained you. So if I take A, B as initial numbers, the next number will be addition of the two numbers. So C is equal to A plus B. Later A and B will be changed. So this is the logic, and we initially labeled as A11. So that next number will be 1 plus 1 2. So this is the logic primarily that we know. But the same problem asked to write using functions. Out of the four classifications which I discussed to you, you can write this program using any four. That means sending the input output, or sending only input, or sending only output, or without sending anything. You can write. Just look at this one. I have used function called functioyn. You know the syntax of function. Function, square brace, means inside the square brace output variables equal to function name or file name. I told you already this normal parentheses, and inside this normal parentheses you use the input variables. And I am trying to reading the n input enter n value means how many numbers I want to print Fibonacci numbers. So that I will use input. So n will be my number. Like I say, I want 100 till 100. I want to print Fibonacci numbers. So n will be 100. So this is the logic. Now look at another M file I opened. It's called run M file, run fib. And here if you look at, I used a function called disp, DISP. So I already told whether I can go for fprintf or disp. I use a disp. It's an output statement. This the sequence of Fibonacci numbers, and then I call fib function. You look at here syntax fib. So when I run this file, when I execute this file, the control will come here first. It will display whatever statement I have printed, and then the control will go to fib. So the control will automatically go to where the fib is. Control will automatically go to the fib, and then it executes. If it executes, what will be printed? Fibonacci numbers. So your output will be printed. But look at the program. I have not sent any input. Look at it is empty. It is void. I have not sent any input. I have not taken any output. Both are vacant. Both are void. Just I called fib function. That's all. So the control will go to fib and then executes. It prints. Let's say next classification. If I want to use something in input, writing the program using some input. Look at factorial. So you know what is factorial? Logic. Factorial. 3 factorial. 3 into 2 into 1. N factorial. N into n minus 1 into n minus 2 till 1. So you know the logic. So this is logic part. What I did, I use the same function, use factorial, and I sent one argument called a. Now look at the run factorial. Run factorial. S is equal to input of enter the number. Why I am reading n? Because I want what is the factorial of some 10 or 15 or 20. Let's say for example I want factorial of 30. I should read 30 from the input, from the keyboard. So s is equal to input. So now that value is stored in s. Now factorial of s, I am sending s in the factorial function. So whatever s is written here will be as an input for the function called f factorial. That means, let us say if I read s as 30, factorial of 30, that means control will go to here and 30 will be copied here. Now a is 30. Now a is 30 means I loop from 30 to 1. Logic will run. So 30 to 1. So 30 into 29 into 28 into till 1. So factorial of 30 will be printed. What I did here, I just sent an input argument as the number which I want to print. That's all. This is a second classification. Writing the program using functions by sending the argument. What is the difference from here to here? There I have not sent any input. Here I have sent input. Even this program can be written without sending also. How we can do, tell me? This program can be written using functions without input, without output. How? Instead of reading here, you just read here itself and don't call any input here. Just call factorial function. That's all. Just as I'm calling fib function, just call factorial. Don't send any input. And that input you read here itself. In this function only read or input as n or a input a. That a can be read. So this will keep it as blank. So now this will be a program with no input, no output. Is it clear or not? So only thing is the logic is same. Just I am keeping in the form of functions. Just look at here. Finding the reverse of a number. The logic is same. I'm just calling, reading that input value and sending that as an argument. So in the end practical exam, you may be asked to write program using functions means you have to write like this only. If you write without function, so I clearly mentioned in the exam, write program for reverse of a number using functions. You can go any four classification with no input output, with input no output, with output no input, no input no output. So this is a program where you are sending the input argument. Palindrome. The logic is this part. I just used a function called palindrome. I read two arguments, two inputs, and the two inputs I am sending here, and with those two inputs I am writing the logic. Multiple inputs. Functions with multiple input arguments. Okay. Look at Pascal. Pascal triangle. You have print a triangle. Binomial coefficients. So three inputs I have read, and I have sent three inputs, and the logic is same. We have done all these things. And Fibonacci prime numbers. Four inputs. So very simple. If the question is asked in the exam, write program using functions. What do you do? It's very simple to start with the first one. What is the first one? No input, no output. Just keep it in the function. Just you keep your complete logic here itself. Just call the function, control will come and run it. Over. If you are confusing by sending the argument, receiving the argument, if you are confusing, stick to the first one. No input, no output. But you are using functions. The function calling is there, function retrieving is there. క్లియర్. ఇక్కడ నేను చేసింది ఏం లేదు, యూజింగ్ ఫంక్షన్స్ అని అంటే మొత్తం నా లాజిక్ అంతా ఇక్కడే పెట్టేశాను, ఏ మార్పు చేర్పులు లేదు. జస్ట్ ఒక ఫంక్షన్ టైటిల్ రాసుకున్నాను, ఆ ఫంక్షన్ కింద కాల్ చేసుకోవాలి అంతే. కాల్ చేయగానే కాల్ ఎక్కడికి వస్తుంది, కంట్రోల్ ఎక్కడికి వెళ్తుంది, రన్ అవుతుంది. Very simple to attempt. Why I'm stressing is definitely I'll ask. Maybe few of you get program using functions. Then you should not surprise. I may not pose you to do only inputting or take the output. I won't pose because you're already in lagging. So I don't want to stress this. But definitely I'll ask using functions. I'll stop there. Then using functions means any of the four you can attempt. So better you attempt the first one, or if you are interested, second one. Nothing is there in the second one also. Whatever you want to find the factorial, you that input you do it here and send it by input argument. If you are good at your C language, calling functions, call functions will be simple. Fine. Now, number with words. For example, 321. In the screen, it has to be printed THREE, TWOONE1. If any number, if I give, in words, I have to print. Fine. So that I used the using switch statement. So any doubts now? Now we are moving to the actual part of the syllabus. So we are moving to the actual programs which are listed in the curriculum. So we start with the gravity flow tank. So when you look at the gravity flow tank, whatever the final equations in solving the gravity flow tank, when we model it, we'll get the differential equations. Now how to solve differential equations in MATLAB? Because you already know how to solve linear equations, simultaneous linear equations, we have done using F solve, F0, but differential equations how to solve. So we use for differential equations, maybe if you go to numerical methods, there are different numerical methods available to solve the differential equations. Euler's method, Runge-Kutta method, Milne's predictor corrector method, Smith method, steepest descent method, which I have seen in the optimization. Those are all earlier versus numerical methods to get solve the differential equations, sometimes partial differential equations. But now we will only look at the differential equations, that too only IVP problems. That means initial value problems, not boundary value problems. So you might know the difference between initial value problems where the conditions are posed at the initial value, maybe at the time t equal to 0. Boundary value problems, when you look at any difference element, sometimes the condition will be given at the extreme ends in the heat transfer. In a shell and tube heat exchanger, maybe after 10 meters length, the conditions will be given. That's called boundary value problems. So we won't touch the BVP, we will touch only IVP problems. Let us look at how to solve IVP problems using MATLAB commands. So we have three functions usually called ODE23, ODE45, ODE113, ODE123, ODE145. There are different versions of inbuilt functions available to solve the differential equations in MATLAB. So these are all called based on RK method, Runge-Kutta method. So you know what is Runge-Kutta method? Perhaps you might know. So there are advantages of Runge-Kutta method if you look at the numerical methods textbook. Look at the accuracy. So he has mentioned for different input functions which is available in the MATLAB. OD23, OD45, OD113, OD123, OD145, OD325 is also there. So every method has its own stiffness or accuracy. And in fact, if you look at the variation, where is the Runge-Kutta method varies? Usually you might have seen RK fourth order method. What is this fourth order? What is that for? No one is strong in mathematics. What is 4 in the Runge-Kutta fourth order method? Even if you look at the formula also you can say Runge-Kutta fourth order method, this is the formula. These are called four slopes. If you are using four slopes, it is called fourth order method. Four slopes. We use four slopes. That's called fourth order method. Anyhow, so let us look at the differential equations, how we will solve. So what is the usual definition of a differential equation? What we will see is dy by dx is equal to something, a function. Dy by dx is equal to some function of x comma y. Now what is y, what is x? What is y, what is x? Y is dependent variable. X is independent variable. That's what we know. So when you are using ODE 45, the syntax for ODE 45 is the syntax for ODE 45 is use a square brace, write first independent variable, write comma, write dependent variable, close the square brace, write equal symbol, write ODE 45, then start normal parenthesis, use single quoted to write the file name, write the interval span, write the initial condition. The syntax for using ODE 23 or 45 or 113 syntax is same. Start with square brace, write independent variable, comma dependent variable equal to ODE 45 or 23 or 123, which you want to use. Basically, stick to only one function called ODE 45, because every time only one method you can implement to all, so that you can accuracy can be checked. And then write the file name in the single quoted, write the span, in which interval you want to integrate, and then write the initial condition. Let's see here. Return dy by dx to f of y comma x. Dy by dx to f of y comma x. So I have written. See, when I'm using functions, you know the function syntax. Function, output variable, file name, input. So dy by dx, I may written as dy by dx. Whatever may be the output variable. Function output variable is equal to file name, independent variable. So just look at one problem. Just look at the problem here. A fluid of constant density starts to flow into an empty and infinitely large tank at 8 liters per second. A valve regulates the outlet flow to a constant 4 liters per second. Derive and solve the differential equation describing this process over 100 seconds interval. So this is not a simpler simple linear equation to solve. You will end up with a differential equation. How to solve? First of all, we need to derive. That's what he is saying. Derive first, and then solve. How do you derive? Keep mass balance equation, continuity equation, transport phenomena. Input is equal to output plus disappearance or reaction plus accumulation. Here only single fluid, so there won't be any disappearance. Input, output will be there, accumulation will be there. So what is input? 8 liters per second. What is output? 4 liters per second. So what is disappearance in terms of mass if you write? because 8 liters per second he has given 4 liters per second. So if I could do d of rho into v by dt, accumulation term. Rho into v means mass, volumetric density. So d mass per density dt is equal to what is out, what is in, into rho. Because I am writing in terms of units consistent. Because liters per second multiplied by the density. So that I will get consistent units, mass per unit time. Just mass balance equation I have posed, nothing else. So the density can be cut down, and 8 minus 4 is 4. So dV is equal to 4. dV by dt is equal to 4. So I end up with a differential equation. You look at here, I end up with a differential equation. So the derivation is over. Just mass balance. Continuity equation I have posed and I got dV by dt is equal to 4. Now I need to solve it. Because the differential equation, definitely I have to put up ODE 45. Now look at how I have written. What is the syntax I told? Function, output, file name or function name, dependent variable, dependent variable. So dv by dt, function, because dv by dt something, some variable name dv dt I kept, some variable, which are variable. Some file name should be function name, already told. File name should be function name, and the variables. Now what is the equation for dv dt? You have to write here. So here there is no equation, only numerical value came. So you just write dv dt is equal to 4. If the equation comes, you have to write the equation. You will see that also. Here only we got numerical value 4, we have it. Now we need to run. So we have to run by calling ODE function. So I am calling ODE function. What is the syntax for ODE function? Independent variable, dependent variable, ODE function, single quoted file name, T-span. T-span means interval span. What is given? 100-second interval span. That means 0 to 100. So I have written here T-span is equal to 0 to 100. That is T0 is 0, TF is 100. T-span 0 to 100 because he want 100 seconds interval integration. So 0 to 100. That's why I kept the T-span as 0, 100. T0, TF. T0 space TF. And then initial condition. For all ODEs, you need to give some initial condition. Before to start integration, I have to give some value, guess value, which you are solving the optimization. We need to give some guess value. So initially I given guess value V0 as 0. If I don't know, I will give 0. So I given initial value as 0. So if I run it, this differential equation is solved. And I am using plot commands. Just now I told you plot. Plot T comma V of colon comma 1. What do you mean by V of colon comma 1? All in the first column. I already told dot. So if I plot that commands, look at the graph. See, in the plotting I have not used any colors. Default came blue. I used X label, X axis title as time. So time came. You look at here, time came. Y label used. I might have used title also. See, title is example 3.1. So somewhere you see example 3.1. Title also came. Is it clear? Is it clear? Very simple. See, what I did is you look at solving of ODE 45. Look at solving. Always when you want to solve differential equations, you have to open two M files. One M file for the function, another M file for the ODE. So this file is for the definition of the function. What is definition of the function? What is given? You have to represent that. Function, output variable, file name or function name, what are independent dependent variable. Write the expression of the differential equation. Close it. Open one more separate M file. Define your ODE 45. Write all the limits. What is your span? What is your initial value? And write your what is plotting commands. You need to run this file, but not this. I already told so many times. You cannot run the function defined files. You have to run always the whatever the executing files where you are executing. This is called run file. This only you have to run it. This you cannot run. If you run this one, you will get an error. Now, what is the meaning of this graph? Ultimately, you tell me. Go through the problem. Look at the graph. What is your interpretation? There is some fluid is sending to some tank, and he has given some what is inflow, what is outflow. He wants to see the derivation and then ultimately solving of the differential equation for a span of 100 seconds. So I have solved and I plot. The plotting says when I increase the time, the volume is increased. If I increase from 0 to 100, my volume is increasing from 0 to 400 in liters. Now, what is my interpretation? Why I want this solution? ఎందుకు కావాలి ఈ సొల్యూషన్ నాకు? ఎందుకు సాల్వ్ చేస్తాను డిఫరెన్షియల్ ఈక్వేషన్? ఏమొచ్చింది సాల్వ్ చేస్తే నాకు? Ultimately, what I am getting after solving, after getting a just plot, is not my interpretation. Look at the graph. When you are increasing the time, you are getting your volume increasing, and that means at any point of time, for example, after 40 seconds, what is my volume? So that gives an indication at what time I have to stop my tank, because tank may overflow. Because my tank volume is, let us say, 200. And if I go to 100 seconds, I'm reaching 400. So that means what? Overflow. Overflow. If the liquid is hazardous liquid, gone. So that indication, that solution is required. If I solve the problem is simple three lines. But the three lines will give a solution where to stop, at what time I have to stop. Otherwise, overflow will occur. That is what the interpretation of differential equation solutions. Without interpretation, without knowing the knowledge, if you solve that, does not make any sense. Just go through the graph, time versus volume. So at any particular time, you can pick the volume. At exactly 50 seconds, what is my volume? You can pick out. Exactly 50 seconds, my volume is something around 200 liters. If my volume of the tank is, let us say, 200, I should stop below 50 seconds. Otherwise, overflow will occur. Is it clear? So only part that is difficult is framing the equation, differential equation. If this differential equation is given, you are simple to execute and write. Is it not? Whenever the problem asked, like in transport phenomena, derive, you will stuck. Because you are not confident enough to use material balance, mass balance, continuity equations, or energy balance equations, or component balance equations. If you are good at those things, you can able to solve the differential equation. If you got the differential equation, you can able to. It clear? Let's look at this problem. Series reactions. A gives rise, B gives rise, C. Series reactions. A gives rise, B gives C. Component balance. Component balance. Modeling and simulation law. Lieben textbook law. Component balance is ఉంటుంది. So I just used kinetics. Normal kinetics, rate expressions రాయడం dCA by dt. So three equations. మూడు డిఫరెన్షియల్ ఈక్వేషన్స్. ఇంకా డిఫరెన్షియల్ ఈక్వేషన్స్ ఇస్తే రాయడానికి ఎంతసేపు, ఇవ్వకపోతే డిఫరెన్షియల్ ఈక్వేషన్ ఎలా డైరెక్ట్. సో కాంపౌండ్ బ్యాలెన్స్ ఈక్వేషన్ వస్తే మనకి డిఫరెన్షియల్ ఈక్వేషన్ వచ్చింది. ఇంకా రాగానే ఏముంది, వాడు ఏమేమి కండిషన్ ఇచ్చాడో చూస్తాం. చూడండి, K1 ఇచ్చాడు, K2 ఇచ్చాడు, కాన్సన్ట్రేషన్ ఆఫ్ కాంపౌండ్ A ఇచ్చాడు, కాన్సన్ట్రేషన్ ఆఫ్ కాంపౌండ్ B C ఇచ్చాడు. చూడండి ఏం రాశాను, నేను కోడ్ రాశాను. ఫంక్షన్ dc by dt, so dc dt sum name is equal to file name, function name, independent variable, dependent variable. Then I have to write the differential equations. So there are three differential equations now here. I have to write all the three here. How I will write? Very simple. Write one equation, keep semicolon. Second equation, keep semicolon. That's what I did here. Look at here. dc dt is equal to c minus k1 into c of 1, minus k1 into c of 1, because all the concentrations, concentration of A or B or C, whatever the component, I all represent with C only. With 1 2 3 already I told, only one variable name can be used to access the different columns. So C of 1 represents concentration of A, C of B represents concentration of B, C of 3 represents concentration of C if it is there. So you see, K1 into C1 semicolon, K1 into C of 1 minus K2 into C of 2, K2 into C of 2, K2 into CB means C of 2. Close it. Okay, open another M file, I already told. Now what M file I have to open? For ODE 45 I have to open. Yes. So I have opened another M file, ODE 45, file name, T-span. What is T-span here? Because in the problem it has given. Till what time we need to integrate? Initial condition. Because three components are there, we have to use three initial conditions. Because A, B, C. A, B, C. A I took 5 because in the problem might be given 5. Or I may have guessed. You check the problem. So use it and try to use plot commands. X label, Y label, listen, title, and what are the values given initially, K1, K2, etc., you can put it. You know, A gives rise, B gives rise, C. A will get drop, but B slowly increase and then get drop because B has to form C. B is product only for some time, then it will be reactant for C. B will increase and then get drop, but C will increase. So A, B, C. So I use it listen. Yes, I use it listen. I use different colors. Plus star. Any doubt? So if you know the differential equation, the conditions already given, you see the conditions, CA is equal to 5, CB, CC is equal to 0. At the time t is equal to 0, that is initially he has given the conditions. If you want given, I will take 0, 0, whatever the previous case problem. Here already t equals 0, he has given conditions. Okay. Now let us not worried about this high rod roadies because it will be difficult for you. So I'm skipping this part. Now let us look at the gravity flow tank. So you have seen this gravity flow tank. The flow will take the gravity, come down, and then the product will be taken out at the bottom. Now if you look at the gravity flow tank, majorly they will use force balance equation and one continuity equation. You open a Leuben textbook, there will be one continuity equation, there will be force balance equation. Obviously, there are differential equations only. So differential equations means we have to rely on O45. That's all. So if you open Leuben, you might be given a table 5.1. Data of ID, area, length, etc., etc., steady state values. Why this data given is you can substitute some of these data values in this equation to end up with two differential equations. These are the final two ODE equations. These are the final two ODE equations after substituting the data values. Now we have to use these differential equations. Two differential equations. But the one problem is if you understand these differential equations, look at carefully. Your dv by dt is function of v as well as some other variable called h. And your dh by dt is function of other variable called v. Multiple variable functions our differential equation has. Now for these problems, what we do is we use same terminology, but we use a function called zeros. Initially we will write zeros. Two equations are there, that means two rows, one column. Use the zeros of 2, 1. Initially we will keep dv as 0. We use this statement. And rest of the things same. When I am solving two differential equations, because after dv on gravity flow tank, dv1 of dv2, first equation is dv1, second equation dv2. I assume v of 2 as h and v of 1 as v, velocity, height. And this file is over. Now I open another M file and I am trying to use ODE45, T1 V1, T2 V2. Because why I written two ODE45 is there will be two initial conditions given in the Leuben textbook. If you understand gravity flow tank, he has given the simulation for 50% design flow rate and 67% design flow rate. These are two conditions given in the Leuben textbook. One is for the 50% design flow rate, other is for the 67% design flow rate. And you want to see whether at the 50% design flow rate the tank will overflow or 67% the tank will overflow. And these are the initial conditions for 150%. This is V here, H here. V here, initial conditions. And similar other flow rate, V here, H here, I have substituted V here, H here. And if I plot, this is the plot in Leuben for 50% design flow rate and 67% design flow rate. See, the height of the tank is 7 feet. And if I operate 50%, I will get overflow. So I need to operate at 67% so that it will be less than the tank height. And if we simulate in MATLAB, we will get plots similar to that. the blue curves, and the green curves are the velocity curves. Here he has plotted only height plots, but I have plotted both height and velocity, both h and v. So we will get same similar plots, but we won't get exact plots. The reason is he has plotted those things in Fortran. Look at Leuben. He has written in his second page itself. He has written, I have used Fortran coding for all the plots. He has mentioned. Leuben has mentioned. At that time, Fortran is the biggest language. Even C is also not that much huge language to be used. Fortran he has used, and almost we get similar sort of curves. Go back again. I'll let me see the code here. Look at the code. See ODE 45. Look at the span. Look at the conditions. Use subplots. Why I'm using subplots? Because I'm dividing. Okay. So only thing is this differential equation. This differential equation. If this is given in the examination, rest of the part you can solve because you know ODE definition, you know conditions. But in the examination, this equation will not be given to you. So I may pose a question with giving this data, with changing the values, and get the differential equation and simulate it. Because you don't know how these equations came using this data. Many students does not read that data, how the equations came. Because from this force balance, you don't know where is my length of the react here, where is my other data to keep. So this data can be kept here to get those equations. That I don't think you might have used. Fine. So let us look at interacting, non-interacting systems. So you know the difference between interacting and non-interacting. Two tanks, how they operated. So for example, let us say if it is a non-interacting case, there will be a balance on tank 2, and there will be resistances, and R1, R2 values will be given. A1, A2 values will be given, and if you substitute, you will get two differential equations. If you get two differential equations, then you will get a plot like this. So as I told, when you are using variables with different notations, go with zeros concept. Define f is equal to zeros of 2 comma 1. Then write the two equations. Then close the file, open another file, write ODE, and execute. The same case with interacting. It will be another equations, sort of equations. Tank 1, tank 2. Only one ODE. Look at ODE. Where is the T span? Okay. The batch already we have seen just now. The what we have seen is a batch reactor. So if you know those equations, you can simulate it. So on the monitor, your C has to drop down, your B has to increase and then drop down, your C has to increase. So this plot is you have to produce when the question is given in the exam. So we are almost end. So bubble dew-point calculations. So you know Raoult's law. YIP is equal to XAPA sat. You know Anthony equation. So I just limited to bubble and dew pressures only, not temperatures, because temperatures will be iterative. I just skipping those part. Only I will ask in the bubble and dew point pressures. So I want pressure versus composition plot like this. Fine. So there are other parts which I am skipping. Plug flow reactor we can also do, because plug flow reactor performance sequences are given, conditions will be given. Fine. Differential equations given, conditions will be given, just like a batch reactor. So batch reactor and plug flow reactor performances will be similar if for the liquid phase reactions. So almost similar. Only differential equations, if you know conditions, you know you can simulate it. So if you get simulation, more or less for the batch reactor, the performance will be same. Okay. So the rest of the part I am stopping, because I don't want to, because only 3 weeks are left. I don't want to disclose open loop, closed loop, and the non-isothermal CSTR. There are other things to be followed. So I skip. I want to skip all those things. So there is a distillation column. All the things are there, but let us not worry about those things. I'm just limiting to only 5 programs in your record for the curriculum: gravity flow tank, interacting, non-interacting, one batch reactor, one plug flow reactor. Batch reactor, plug flow reactor, interacting, non-interacting, gravity flow tank. Lastly, the dew point, bubble point, pressure calculations only, not temperature calculations. These only will be reflected in your record, reflected in the record. Apart from the previous programs, which I will keep it in your group. The previous program is whatever you have already done, Fibonacci numbers or prime numbers or reverse number, only very simple programs. I'll give 5, and rest of the 5 or 6 which I discussed now will be there in your record. Okay. So 3 lab hours will be given to simulate all the programs, because I am sending all the codes to you. I explained, I am sending. Usually I explain only, I won't give the code, because I ask students to do, but because of the time lapse, you are having very crucial time of 3 weeks. I'm just send the code also. So use the code, concept is clear. Now you implement to get all the 5 programs done in the 3 weeks, because your timetable is also ready. Soon it will be displayed. So your exams is as per the time. Clear. Before Pongal only your examinations, not after Pongal. Already timetable, everything has going to release. Fine. There is no extension, or there is no postponement. Clear. Because your semester is very lagging, and you have to leave taking the 4-2 degree by May 30. So that's why they have planned like that. Okay.